I am Nevin Liber. I work at Argonne National Laboratory in the Argonne Leadership Computing Facility. And this is my talk on the many variants of standard variant. This is basically the history of what it took to get variant put into C++ 17. So briefly, bonus points if you can find me in here. I'm actually like right there. It's very scary because these are like the official like Argonne ALCF slides, and now I'm immortalized in them. So, what do we do at Argonne? We have the number 2 fastest supercomputer in the world now, Aurora. I forget what magazine that got rated in. And we're just trying to make the world better. We're funded by the Department of Energy and open research. A lot of physics, material science. We're working on our own AI to solve scientific problems. So what do I do? So at Argonne, I work on basically 4 things. I work on C++, on SYCL, which is a performance portability layer for GPUs. Cocos is one that started out of Sandia Lab. That's a library performance portability layer. And Aurora is our supercomputer. On the C++ committee, I'm the vice chair of the Library Evolution Working Group Incubator. What that is we get proposals in shape for the bigger library group to take a look at with the first view. I'm also the admin chair, which means I'm responsible for getting things like mailings out, making sure like the infrastructure is working. I don't actually rate the infrastructure, but like people come to me first. I'm also in the US delegation. I'm the vice chair. And I'm also on the Chronos SYCL committee, where I am the C++ availability test subgroup chair. So as we're trying to put things from SYCL into C++ and vice versa, I have a subgroup that we work on that. So what is a variant? Right? It's a discriminated, tag type-safe union. Right? It's a union that knows what it's holding, which is what the normal C++ union doesn't really know. I know very little about type theory, but it's a right. Product types are like structs and class, and generically a tuple. A sum type is a union or variant. So you're going to learn all I know about sum types. In C++, we added 3 of these for C++ 17, any, variant, and optional. So any, it's a concrete type, right? It doesn't have a template parameter. Discriminated type, it knows what it holds. It's an open sum type. It's not a limited set of what it can hold. It can hold anything that's basically copyable. That's the type requirements. It's got the CPP 17 copy constructible requirement. That's pre-C++ concepts. So it's a syntactic, not a semantic requirement. Uses type erasure in internals, which means it generates the equivalent of a virtual function for the operations it needs, like copying, getting things out, etc. And part of this means you need a virtual function for cloning the object, even if you never copy the object it's holding. The code has to be generated, which means your type has to be copyable even if you never intend on copying it. Here's roughly what an implementation looks like. You can really fit it on like 3 slides if you really want to. Like internally, it's got a pointer. Unique pointer works very well for this. And then the clone function basically has to make the copy, and that's the thing that's always generating code. Right? Unlike templates, right? If you have templates, something you don't use, you don't generate code for it. That's not true here. And move constructor. And because any can take any copyable type, you have to be careful with those special member functions to make sure they're the ones being called. So there are space and runtime efficiency concerns with doing this, right? The held object is either going to be embedded inside using the small object optimization, or it'll be on the heap. If it's too big, or if it's move constructor can throw. But because the move constructor is no accept, right, that's kind of the requirement this forces. And we'll dive why we want that to be no accept. That's actually a desirable property, but not always easy to achieve. And another problem with this is there's no control over the allocation. We don't know how to store a type erase allocator in a type erase class. Some people thought they did, and there were versions that had that as the interface, but it was never implemented. Another runtime efficiency concern is how do you, if you want to figure out what type does it have inside, it's basically cascading ifs. So that's order n. If you don't know what type it already holds. So why is no except move construction desirable? Dave Abrams, and these are all, back when we were all, pictures of us are all younger and more naive and less stressed out over the world. He came up with the exception safety guarantees. Right? The basic one means the invariants are preserved, no resources are leaked, but you may not know the exact state. Strong means either the operation completed or it did not. There's no middle state. You know whether it worked or not. The reason we don't always do this is that it can be expensive or sometimes impossible to achieve. So the basic guarantee gives us efficiency, but this gives us much easier to reason about code. And then there's also no throw. To build things like strong, you need operations that you know will not throw. Like swapping two integers, you know that will not throw. You can build things on top of that. And composability. So optimizing when we need the strong guarantee. Like if you want to grow the internal size of a vector, right, you allocate new space, and if it has a throwing move, it copies the elements. If it has a non-throwing move, it can move the elements and release the old space. So clearly more efficient. This is a lot of the reasoning behind why move semantics were added. A lot of it was to support vector. It's just a more general way to support vector. And why do we need the no-throw guarantee? It's like to do swap, right? If we know that these cannot throw, then we can do swap, and we know swap will leave everything in a usable state. So what we're going to find out is throwing move constructors, they just don't play nicely with variant, and I have a lot more to say on that. So variant is the next type in here. This is a templated type. It has templated parameters are all the different types it can hold. It's discriminated, right? It knows what it holds, and it's a closed sum type. It holds one of possibly n types. And I'll refine this definition as we get through the design choices. I didn't say exactly one, I didn't say at most one, and we'll get to that. So because the set of types is specified, we have space efficiency. We know what the biggest types are, we know how much space a variant will take. There's no heap allocations. And we can do runtime efficiency because we can do visitation. And then we have optional, which is again a templated type. It's a closed sum type. It holds at most one of the templated type. It could be a refinement of variant. It's certainly an easier interface, like dereferencing to just access the object. And it's very useful. It's a very common case. And we have the C++ committee. This is probably from 10 years ago? I don't know. I don't remember where these pictures came from. There I am, because when you take the picture, you're not in it. Every committee member, you wish big governments worked this way, right? Every committee member wants to make a better language, even if no two of us can agree on what that means. And ultimately, it becomes a consensus of countries. And as the Rolling Stones say, right, you can't always get what you want, but if you try some time, you find you get what you need, right? And you learn, you got to fight your battles. There's a lot of battles on the committee. We're all exhausted after a committee meeting. We have a meeting next week in Poland, and we're all going to be exhausted by Saturday, I'm pretty sure. And fight for what you can live with, right? It's, consensus, it's not designed by committee, but it is consensus by committee. So just decide what's important to whatever feature you want added and what you're willing to give up. And if it doesn't meet your needs, don't be afraid to say, this is not going to meet my needs anymore. Someone else, if they want to go in this direction, will need to take over if they want to put this in the standard. It's not a threat. It's just that you're setting your boundaries, saying, doesn't meet my needs, I don't need to do this work. And it's not necessarily your ideal design, right? I'm not trying to convince anybody here that what we've ended up with in Variant was anybody's ideal design, but it's the one that got us consensus to get through the committee. And we do sweat the details, right? They matter, right? We know millions of developers will use what we come up with, and they will model their own designs on what we do. And there's a very high bar, and Titus touched on this morning, for backwards compatibility. It's not 100%. We are willing to break things, but very carefully consider doing that. Because we know it's very hard to fix things later, and people are dependent on what we said, this is how something works. So there are really kind of 5 major things that went into the design of Variant. The never empty guarantee. How should assignment work? How should comparisons work? What should default construction do? And how do we actually access the element? And for all this, it's really just trade-offs, right? A lot of people think, my design's right, everybody else is wrong. That's not really how it works. We all have different experiences, we see the world differently, and we make different trade-offs based on that. And so in designing a variant that everybody can use, right? There are space efficiency questions, there are runtime efficiency, there's compile time efficiency, and usability, and all that matters. And we're all going to see it differently, and what's the right way to do this. So never empty, right? Ideally, a variant has a never empty guarantee, right? Models exactly one of the bound types. There's some issues with trying to do that. So what if we relax it to modeling in most one? Like, how does it affect the various trade-offs? So we have a variant AB. Starts with an object A, and you want to assign a new A to it, right? And the question comes up, if A has an assignment operator, should we use it? If the answer is yes, it's because you're assuming assignment is an optimization over destroy then construct. But what if it doesn't have an assignment operator for whatever reason? We can still do destroy and construct, right? It's a library type. We can do whatever we want. And then the question comes, should we always do destroy and construct? And the argument for that is it would be consistent if we always did the same thing. Consistent with invariant, but inconsistent with the rest of the world. And place is a little simpler to talk about. It has similar issues. And like for this, right, user expects V1 to hold the B object. But if we're not double buffering, we need space, right? So we do destroy, then construct. And what happens if that throws when you're trying to construct it? It turned out that was the most contentious question in the design of Variant. Comparisons. Which way do you want them, right? So you have a variant of a short and int. VS3 holds a short 3, VI2 has an int 2. So if you compare alternates and then values, you're saying, okay, if it's short is less than an int, and then compare its values. So you get like, the 3 short is less than the 2 int, if you do it that way. Or you can just compare values. And you get 2 is less than 3. That's not surprising, right? That's what people expect. But to do it that way, you need to generate all the code for the entire cross product of all the types. Right? It has to be right. Short versus int. And as you have more types, that's not only a lot of compile time, right? It's order n squared. But what do you do with things like a variant of int and string? I mean, you could say, nope, harder. You can't compare these variants because it contains things that are not comparable. You can throw an exception, right? This is part of the design space. The argument that tended to win out, though, is that comparing values of different types can break transitivity. And so, to give that example here, if you're comparing Left side int, right side string, right? You want to do them as string comparisons. So here, if I have, right, integer 200, string of quote 30, and integer 5. So here, 200 is less than quote 30, because the string 200 is less than the string 30. String 30 is less than 5, because the string 30 is less than the string 5. However, if you're just comparing the two that have integers, that fails because 200 is greater than 5, not less than 5. So again, now this is surprising. Right? If I compare values, are these two things really equal? They both contain ints, but they're in different slots in the variant. If you allow types to have the same type in different slots, that's another design point. Is the alternative, is it or is it not a salient feature of value comparing type variants? By the way, feel free to interrupt me with questions. That's fine. So if you compare alternates then values, that's representational comparison. So the result is surprising. Again, right, 3 is less than 2. But types only need to be self-comparable, and that's order n of the code that has to be generated at compile time in usable instead of order n squared. So these are some of the design choices we had to make. Default construction. Should it be default constructible? I mean, that's maybe. If we do use default constructible, should it be one of the bound types? And what does that say? Is that the same as a move from state for a variant? There have been people who've asserted that the default constructible state and the move from state should be the same in good code. I generally follow that principle if I can. I would need a good reason not to do that. But that's not everybody's view. Accessing its element, right? You want to be able to index by type, right? I want to get it out if it's an integer. Or I know it's in slot 4. I want to get it out, whatever the thing is in slot 4. Because I have a variant of int, string int for whatever reason. Should we have better than order n to access it, right? Ideally, we want order 1. Right? We want these things to be efficient. And without language support, the only thing we've been able to come up with is visitation. Let's do that. Okay, now's the part of the time you guys get to become committee members. So you have a variant, holds an A, you assign a B, and the constructor for B throws. Let me find another. You guys can tell me what you think it should do. If I can find my cursor. What should it do?
Go into the woods.
Oh. Interesting. Oh, I guess I have to.
Nevin, just to make clear, you're saying the move constructor of B throws, not the default constructor as the argument of the assignment throws. Okay.
It should really be mplace and then mplace throws, but it's the same issue, yeah. Because you've already destroyed A. Oh, there he goes. I'm going to hate typing, but that's okay. So what should it do? What would you like to see in your perfect variant?
Variant should go back to A.
Okay. How would you do that? I mean, just a rough outline, not like.
I would have to.
Because A's been destroyed.
I would either take a copy of A and then destroy it, and then try to construct B in place. And when that
so copy A, right? Then destroy, right?
Then destroy
This
the original. Yeah.
Okay.
And then you, when it doesn't, when B fails, you put back the original A.
Unless that fails too. That's okay though. No, this is a brainstorm. That's okay.
Throw again?
But that doesn't, okay, so you keep going, so the whole object, but the object has no state, right? You hope it goes out of scope and just gets destroyed. Okay, that's fine.
I would say now V1 should be undefined because we have to be consistent, destroy, then construct. So even we now trying to assign V1 with a B object, we are destroying it already before we try to construct it.
Okay. So basically, yeah, undefined behavior. Peter?
Make it not compile if B's move constructor is not no except true.
Another option could also be that we weaken the general definition of variant so that we can have a variant in an undefined, not undefined state, but like in a not A, not B state, like in an empty state. Yeah.
Yeah, with an empty state, okay?
Basically, if the move constructor is not no except, use the copy constructor, construct a temporary of B and assign it. So if the B is not constructed,
Okay, so if the move constructor is
because it
not
throws
no
an
except,
exception, it has already thrown before V1 is modified.
okay, if the move constructor is not right, not no except, then copy?
Copy, yes.
Okay. Anything else? By the way, at the end of the talk, we'll see how many things the committee covered.
Maybe just like default construct the variant, whatever that does. So like default construct A.
Anything else?
First construct B, then swap with A if it doesn't throw.
If swap doesn't throw, right? No, this is why this is hard, right? There's a lot of choices, right? Any more? Okay. Let's see if we can get this working again. There we go. Yay. Oh, you'll see the arguments coming. So variants have been around a long time in C++. So Boost.Variant's been around since 2004. It was added in Boost 131. It has a never empty guarantee. It has interesting semantics for assignment. It's sometimes default constructible. It does compare alternatives and values, and it has visitation. Right? So this will use assignment. And it talks about like some of the design considerations it went through. It's like the ideal solution, and then Dave Abrams says it can't work. Like provide backup storage, like memcopy, destroy, etc. I'm going to show you pictorially what this looks like. So you have an object A. You then memcopy A somewhere else. Construct B. Memcopy B over to here. Memcopy A back here so you can destroy it because its address may be important to its destruction. And then memcopy B back to here, right? Yeah. Yeah, even ignoring the efficiency, right? Yes, I totally agree. Yeah, this is. So, right, so what happens if constructing B throws? Hey, just memcopy the back, you're done. Right, fraught with peril. Right, as David Abrams said, there's a lot of code to read through, but if it's doing what I think it's doing, it's undefined behavior, because the standard doesn't give license to do that, right? Only one object may have a given address at a time. So then there's the initial solution is let's use double storage, right? So you only store, if you're doing place, you need like the biggest element twice plus a place for the discriminator. It could be 1 byte unless it's more than 255. And you do construct then destroy the order swap, and this completely solves the problem. Has a strong exception safety guarantee, right? Because if you can't construct it, you're fine. However, get can give you a different address depending on when it's called. But the big argument against this one is the space overhead is unacceptable for many users. Right? So this is constructed and destroy. That throws, that just sticks around. So the current approach is a temporary heap backup. So copy it into the heap, destroy the original, construct B, then destroy the A you had in the heap. If this throws, we're still fine. If both of these throw, we're still fine. If constructing B throws, we're still fine. If both of these throw, A has kind of moved down here, but we still have an A, the variant still holds an A object. So that's what Boost does. It is default constructible if the first type is default constructible. And so if any type is no except, default constructible, it will pick that one, the first one of those. And they add Boost blank so you can make this thing that gives you a type that has nothing in it that will not throw in default constructed. Yes?
I'm a bit lost on the previous slide, if you can. So what happens with the A?
You copied A into the heap.
Yeah, but then it should
This
go
throws
up.
that.
Yeah.
This one didn't throw. If this throw, you were done, because the original is still there. If constructing B here throws, you try to construct A. If constructing A here throws, variant just points to this, and the embedded space isn't used. The heap now holds an A object.
But variant is like bunch of memory. It's not the pointer, right?
That's an internal implementation.
All right.
You can see it because you can get its address.
Okay.
So it's observable.
But this solution poses another problem, and is that if we have said that we want an instance of B there and B throws, we should be notified that that is not happening, because it may not be undefined behavior and it may work, meaning
Right. Well,
compile and run, but
the
it's not
exception will
what we
still
expect.
it'll do all this work and then rethrow the exception.
Okay.
You still have to
Okay.
you still have to then handle it. But the state of the variant the state of the variant is that it's got a different A on the heap with a different address.
When is the heap allocation performed? Is it during the assignment, or is it pre-allocated?
Wait, what was that? The first part of that?
When is the heap allocation performed?
Way over here if it has to do it
Okay,
when it first
so during
starts.
the assignment operation.
Yeah, during the assignment operator. Right. This is embedded in the. I don't want to say on stack. This is embedded in the object. The whole object could be in the heap.
Exactly. So it changes the memory, or not?
Right. It will change the address of this, and it's a different A object.
But yeah, that's like, imagine I created on stack. Then where? Like
This is
now it's on heap.
well,
So the memory has changed, right?
Yes. It's a different A object. I was not around when Boost when they picked this view. I'm sure they had a big argument and had to, no. It's a valid question. I don't know why they did it this way. It was before I looked at Boost, but I'm sure These are hard questions. So if the first type is default constructible and it won't throw, the first one throw, it picks that. Otherwise, if any type is no except default constructible, it's, I forgot what it. Oh. And it's unspecified what it has, but you can look at the implementation. Right, so construct, destroy. If that throws, it's got one of your types in it. Element access is via get. You index by type, get int or get string, similar to any cast for any. And you can also do visitation. So that's a function object that knows how to process every type. So you apply visitor, and this knows how to process every type, and that's the variant. And then this can be order one over a number of types. Right, it kind of looks like this. It kind of does look like this. So I wanted to print string or int. So it has a function call operator that takes a string. So if it's holding a string, it will be calling that one. If it was holding an int, it'll call the other one. And it's very weird. This is an inversion of control. And I generally don't like this. Most people generally don't like this pattern. But we, without language support, don't know another way to do it. So element, this is like print via get, which would be cascading ifs, so that's order n. Visitation is order one, but it's an inversion of control, and you gotta write this kind of code over here. And it's just weird. It doesn't really fit in. So before all this stuff made the committee, Matt Gobbold and I came up with, for our company, DTS variant, standard reverse. Because we were at a low latency trading firm, and we were annoyed with Boost.Variant. Because we never want double buffering. We never want a heap backup for any reason. And we almost always added boost blank to everything, so visitors should always have to handle that type. And we wanted assignment to always be straightforward. Just call the assignment operator. So our empty state modeled at most one. If you're changing type, we did destroy construct. If the same type was operator equal, if the exception is thrown, it was in this empty state. Comparisons, alternative, then value. We would default construct into the empty state. And element access was via get and visitation. So we had that. And if this throws, it's in the empty state. So I was very familiar with the, at that time, issues involved. I thought about proposing it. And my company, they were fine with that. We could open source this. This wasn't like the secret sauce for our trading firm. They were fine. But there were a lot of battle scars trying to get optional in the C++14. Optional was in the working draft at one point for C++14. And I think it was Bristol. We couldn't decide how relation operators should work. We had a 7:30 p.m. to 1:30 a.m. without a break. Try to solve this on a Tuesday, and we couldn't come to consensus. And we were constantly revisiting old arguments without new information. People weren't getting their way. They would bring up the same exact arguments. And so it got pulled and got put in on the library fundamentals TS. However, around this time, Axel Neumann from CERN comes to the Urbana meeting in 2014. He wants to do variant. And he asked me if I wanted to work on it, and it said, like, I'll work with you behind the scenes, but I don't want my name on it, because this way, if I don't like how it's going, if my name's not on it, I can walk out of the room. These are stressful meetings. that was my whole argument. So his first version had an empty state. Assignment was always destroy, then construct, even for the same type, right? He wanted value comparison. It default constructed the empty state, and element access was get. And we had 17 people for this discussion. And basically what we said to Axel is like, we agree with a lot of this, not all of it, but you need to explore the design space, because your paper didn't do that. And someone brought up, like, I'm terrified of a world where everyone will invent their own visitor, because he didn't. But there was no better alternative than visitation. And then comparison of values, again, is order n squared to compile time. Bjarne says, visitation is unpleasant. I agree with that. You should just use pattern matching. I agree with that too. Language feature, but it wasn't proposed, and certainly not proposed for the library fundamentals TS. We shouldn't wait for it. So Axel agreed to trim visitation the bare minimum for variant, hoping like someone would do the work to get pattern matching in. So yeah, we asked Axel to do more work. We wanted a tuple-like interface. Const expert was all the rage. Let's make it const expert as we can. Explorer never empty. Do we allow this or not? The same type? Do we allow int and constant? Pre-Lenexa, v2 he shows up with, has assignment and uses, it's the assignment operator of the type if the type isn't changed. Alternative to the empty state, right? Only types that are no except copy constructible, which left out all types that do allocation, like vector and string. Or double buffering, which is, construct and destroy, double the memory. It covered all this. Also comparison by alternative then values. Axel agreed with it because it otherwise breaks transitivity. He still wants it, but he agreed this was the right choice. And then the committee woke up. Hundreds of emails flew by, many of which were mine. I'm just trying to keep the whole conversation focused, and it's a heated, contentious technical discussion. Right? Comparison suggestions, right? Because short is comparable with int, variant short int should not be comparable with itself because of possibly surprising results in order n squared to compile time. Right? Assignment suggestions. If no except moves constructible, construct temporary copy of B. Exception, B1 still has A, destroy A and B1, move construct temporary, destroy temporary. We really want never empty. Some other people said we really want never empty, otherwise it's not quite a sum type. Sean Parent says, how about instead of the empty state, let's have a partially formed state where the exception is known. Right? Sean wasn't there, I got to present it for him. I got it slightly wrong when I presented it, but he corrected me later. Right? So the only things like, assign to and destruction are the only two things he really cared about. I accidentally presented that as that's the only things he wants in it, and that wasn't quite true. And you cannot even query the state, right? He doesn't care. Default construction is not this state. And partially formed is still a sum type. So by not requiring no except move operations, providing the basic exception guarantee becomes complicated. That's why we need all this. Basic exception guarantee, move from state, and default construction are all related to each other. It's the minimum we had to satisfy, but he was fine with more functionality, and he didn't object to having an empty state that you could query. More suggestions, right? Terminate on exception. We're done. Except the user has no way to know that's going to happen. Like I said, lots of emails came by, and I had to, I was trying to tame some of these. Okay, limit types that are no except move constructible. Kind of draconian. Eliminates most legacy pre-C++ 11 types and aggregates of them, which at that time still mattered. It still matters now. It's not portable. Some versions of list move constructor are not no except because they allocate the two ends. And they're allocated on the heap. And types with aggregate them also have this problem, right? And there's nothing visible to show you that, right? Can I store that type in a variant, in that kind of variant? There's no visual cue to say whether or not you can. You have to dive all the way through the code, and that's not portable. Another suggestion, disallow throwing move constructors in the language. It had been tried before. It failed. That had been tried. When move construction was coming up. That was before my time. So make variant a built-in as opposed to a library type. And that is nice for other reasons, but doesn't actually address the problem. Add strong assigned member functions to types which don't throw, and operator, at versus square brackets, people are just going to use the easy one. By far, they're still just going to use regular assignment. undefined behavior, right? That's as bad as terminations because users can't avoid it. Let's standardize all these different things. Only experts can choose between them, and then how do we interoperate between them? Are they convertible? Right? A whole bunch more questions suddenly show up. So the top ideas were double buffering, empty or partially formed state, restrict the types, or terminate undefined behavior. And I had to keep repeating that, because to keep the discussion focused. So yeah, partially formed states, it's gaining, people are coming around to it. Should the default constructed variant be in that state? That's a big question. And Alistair Meredith, very young Alistair Meredith in this picture, says that this is problematic because there's a hidden unexpected precondition on moving and copying. For instance, if you have a vector with one default constructed variant and you grow it, it internally is going to copy or move it, right? When you grow the vector. If the state does not allow this operation, right, you can only destroy it to or assign to it, right? You cannot assign from it. So just doing the reserve leads to bad things. And most types have no preconditions on moving or copying. Sidebar, containers are value initialized when default constructing elements. And this is something some people want to get rid of, and you catch me, after the quiz or something, and I can tell you how the whole story behind make unique default init turned into make unique for overwrite, because at the time there's nothing in LAWG. They always preferred a longer name over a shorter one. Don't ask me why. And that barely made it into C++20. But this is something people want to do. Right? If I have a big array, I don't want to initialize it. But I'm not going to copy that thing. Anyway, variant v2 discussed in Lenexa invited all interested parties, but a lot of members, who normally don't come to the library couldn't make it. There's just too much to do. I strongly suggested an evening session, but to no avail. At least not at that meeting. I didn't really want to be right there, but. So the goal is to answer all the open questions. So 7 of us, and it was not a small group, just looked at it, not contentious at all. Right? Emptiness versus non-emptiness, assignment between heterogeneous variants, can types be supported, right? We went through all this. We then brought it to the bigger library evolution group, 17 people. That was not contentious, right? So the way we do polls, we do 5-way polls from strongly in favor to strongly against. Should we be able to query the empty state? Yes. Should we default construct in the empty state? No. Should we default construct by trying an alternative type till we find one that's no throw default constructible? Maybe. It's kind of 8 to 4. It's kind of on the border. Had lunch about heterogeneous assignment. Is variant short int assignable from variant int short? That's order n squared at compile time, so probably not. Hey, what if we can sort types? I was 99% sure we couldn't sort types, especially things like dynamic libraries and the real practical problems. So I went, informally at breakfast the next day, asked some core people this question, asked them not to laugh, so they cringed at me, but they confirmed my suspicions. They're actually pretty friendly people. More things, remove heterogeneous assignment, yes. Conversions, should we allow variant int string equals the character literal hello? Etc. We're just getting through all these, right? Lots of polls. Should variant int be allowed? Yes. There were some cases people came up with, and mathematically there's no reason to forbid it. It just means you can't do a lookup by type. Allow types to be reference types. Well, optional, we said yes, even though optional didn't support reference types. We're hoping in 26 optional will finally support reference types. Peter can attest to some of that. Should we allow void in there? Sure, why not? Again, we went through lots of polls. Do we do a pointer version of get? So it doesn't throw if it doesn't, if you got the, it doesn't contain the type. Instead, it returns a null pointer. Sure. Default construct in the empty state. No. Pick one of the types. Yeah. First default constructible one. No, we don't want to specify it. Again, lots of polls, right? So we get this, all these are done. We get this variant v3. Empty state, only when assignment fails. Assignment, same operator equals. Failure to change types, empty state. Comparison, alternatives, and values. Only comparisons or variants of the same type. Default construction, first alternative type. Element access, get and visitor. 16 people. One person still wants the default construct initialized to the empty state. Nobody else wants that. You want to be able to query the empty state, have a valid method. Sure, it was borderline. Not really consensus. So the paper doesn't have to change yet. So V4, the empty state when assignment fails and visit has a variadic signature, multiple heterogeneous variants. His assignment when switching types, copy right-hand side to a temporary, destroy the left-hand side, move construct left-hand side from a temporary. This is a pessimization, though. It's a probabilistic argument, but there really was not evidence provided for it. Generally speaking, one should not make claims about optimization or pessimization without measuring, because humans have a hard time reasoning about performance, doing different kinds of work. However, in this case, we are strictly doing more work. Also assumes move is always an optimization of copy, when for types like this, that's just expensive. It's not. It's the same as copy. Still, you should measure. Committee woke up again. I tried counting. It's hard to count email messages in Gmail. And I remember when I wrote these emails, I was grinding my teeth. And doing this talk presentation, I was grinding my teeth for the same reasons. 1,080 at least went by. Half of which showed up the week after the mailing. And every single product was, again, and 2/3 of my email said, does not contain new information. A few more arguments, right? The group that evaluated it was too small. We need more people looking at this because that'll get us a good consensus, good design. Okay. Make it so the folks at C++ now like it because they didn't like what was being done. Head of a national body said, don't even think about putting this into the standard before putting it into a TS. Right? Make it so the active type cannot be changed. Use optional variant if you want to change the active type. Make variant move only, not even copyable. Right? Use transactional memory, because that was a thing that was happening at that time as well. So for V5, valid will get you the visible state, and valid no longer a precondition for copying and moving from a variant. Right? Axel also wrote a competing paper he didn't really believe in, but people wanted it. Default construct to the empty state, assignment, copy, destroy, move, no comparisons. But he didn't think it was going to get through. Then comes Michael Park, who wants an indeterminate state, default construction and assignment failure. He wants type switch instead of visit, right, the precursor to pattern matching. But we sometimes have logistical reasons having problems getting to meetings, flights get canceled, events happen. He didn't actually get to present this. David Sankel, who's here this week, had simply a basic variant, basic exception guarantee, and double buffering unless one of the types is no except default constructible. He had another one, simply a strong variant, strong exception safety guarantee, never empty and double buffering. And then the case for a language-based variant, so he first started adding it then. Kona had an evening session. And the scribe said, if I hear repeating arguments, I'll call it out and stop minuting. He only had to do that once. And really, the only thing that changed it, exceptions on invalid state operations, valid was never a precondition, so no undefined behavior. That's really the only change that came out of this big evening session. And we're encouraging more, pattern matching stuff. But when the committee says no, it means we really don't want to see it again, because mostly if you poll someone, do you want us to do more, do we want you to do more work? Sure, do more work. Why not, right? It doesn't cost the rest of us anything. Except it does. It costs us time to evaluate it, which we ask you to do it. right? Undefined behavior is a precondition violation. So do you want undefined behavior for anything? It depends, right? Unsigned arithmetic wraps, there's no undefined behavior, but it's usually a bug. Signed arithmetic, underflow, overflow, that's undefined behavior, but more efficient. So back to variance. So when not valid, what operations should be errors? That's the question about undefined behavior. Committee struggles with this to this day, right? Contracts are supposed to solve it in 20. Maybe it'll solve it in 26. We'll know after next week. Maybe. But we won't know, or we know it won't be in 26. Those are different questions. So we had an LEWG discussion of 19 people. Allow conversion, sure. And then valid became the opposite of value. It became valueless by exception in the opposite sense. Right? Some bug fixes. V7, I think it was Matt Calabrese said, instead of targeting TS, let's target C++ 17. Because we kind of had consensus at this point. If we wait, all we're going to do is lose consensus, right? People will just... And so Axel did a P088R2, and David Thankle wrote a very important introduction to this, right? C++ 17 needs a type-safe union. I don't normally read everything, but let's not make the same mistake we made with optional by putting this library into a TS. We waited 3 years where no substantial feedback or discussion occurred, and then moved it into the IS virtually unchanged. Meanwhile, the C++ community suffered, and we continue to suffer from a lack of this essential vocabulary type in interfaces. The implications of the consensus variant design are well understood and have been explored over several LEWG discussions, over 1,000 emails, a joint LEWG, EWG session, not to mention 12 years of experience with Boost and other libraries. The last major change made to the proposal was non-breaking and added exception throws, where previously there was undefined behavior. Since then, all suggested modifications have been cosmetic, rehashes of older discussions, or would be handled just as well by defect resolutions. The C++ community should not have to wait 3 years for a widely used library. It's already done, fit for purpose, and has such extensive review. There's low chance we will regret including it in C++ 17, but a high chance we regret omitting it. Peter Dimov didn't like it. He wanted different design. So Ulu, bug fixes, the final plenary, right? You know, we will not accept standard any into 17 without variant, one of the national bodies said. People will use the wrong type. There was a motion, move we applied to the C++ working paper, the proposed working from the final version, type safe union for C++ 17. Unanimous consent, including that head of national body who said it has to go into a TS first. Like, you can get people's minds to change. Issaquah just kind of fixed some stuff up. Here's what it had. So how do we do on our brainstorm? I don't even know where. Okay, variant should go back to A. If can, copy then destroy original. Yeah, people talked about that. Throw again, sure. UB, sure. Make it not compile if B is a no accept move constructor, sure. See, committee covered most of it, right? And a whole lot more. Like, you know, you may not like the decisions we made, but please don't accuse us of not trying to think it through. We usually do far more thinking it through than we really should be doing. But and some more stuff. People wanted some slight changes. Time is running out. You can look at my slides at some point. So is optional a refinement of variant? Not quite, right? There's no valueless by exception state. There's really only 2 states. It owns something, it engages with something, or it does not. But and no support for get or visit, but we could add those. So here's an interesting question. And you know that I'm asking the question, so you know the answer is yes. So Augustine, who's also here this week, came up with this really good example, right? So you destroy the floating point. You want to assign the int, and then when it tries to get it out, that throws, so now you're in valueless by exception. So yeah, that was sad, but David Sankel and a few others have a language variant proposal. So they met in Kona 2019, and Axel and I walk into the room, and we present here's all the questions you need to consider, because making it a language variant doesn't change any of that. And worse, there's things like storing destructors, which the library says we don't deal with that. The language has to deal with that. They need some kind of answer. What should equal default do for assignment? And there's no in place. And anyway, Peter Dimov still didn't like it, so he had his own version for Boost.Variant 2. And basically, it's never empty. It's got the strong exception safety guarantee for assignment and in place, sometimes using double storage. Converting constructor to variant with more types, and you can convert to a variant with fewer types via subset. So if all the types have a non-throwing move constructor, there's what happens. Otherwise, it will use double buffering. Pattern matching. So here's kind of like, at the time, Inspect was going to switch on types. Michael Park is bringing this to try to get into 26. And so here's the current version. Right, so in 0 says if it's got the value 0, then you want this to return -1. Got the type int, you say let I equal I. Otherwise, float, let f equal the integer version of that plus 2. And then you can go read these slides yourself and his paper if you want to see the current state of pattern matching. Will it make 26? Who knows? So for 20, in variant, we made everything const expert that we could. It might be everything. Didn't check. Spatial operator was added. The meta functions of volatile types are deprecated because the library doesn't want to deal with volatile things. 26, we now have a membered visit function. And it looks like we're putting monostate in utility so people can use it for other things. And my closing thoughts. So what do I want in a variant, right? Because people would ask me that, and it's like, the one we actually came up with is actually pretty good. But there's times I want strong performance, right? I don't want, construct somewhere then move. I want, it's very efficient. And there's other things I want strong reasoning. I want double buffering, because I can reason about that very easily. Anyway, special thanks to community, the committee, my friends, my family, especially David Sankel, Sean Parent, Michael Park, Matt Calabrese, and Axel for championing Standardization. I mean, he did the work. And here's the thing he said about the kudos he gave to me, right? So thank you. We got 2 minutes for more questions. Peter.
Yeah, I think you deliberately omitted one of the things that I miss in the standard library, overloaded.
Overloaded.
To create a set of overloads from a list of lambdas.
Yes. Standard overload, yes. Yeah, there was, it is a proposal. I don't know what happened with it. Was it yours?
I tried to write a proposal, but it never, I didn't have the energy to make it work. Especially because pattern matching is again on the horizon.
Yes. Pattern matching will solve all our woes, right?
Actually confessed to me he deliberately omitted overloaded. Well, when did we get inheriting lambdas? I'm not sure. 17 or 20?
17, I think.
Yeah, so it would have fitted in 17.
The meanings all blur together after a while.
Yeah, but let's say, the thing is, Axel confessed to me that he deliberately omitted that from his variant papers to get pattern matching into the language. So.
Thank you. I hope it was insightful and fun.